Hello, today we are doing LeetCode question 746. It gives us a few examples of what we are doing, and I'm going to explain to you the question and explain my process of going through that here before we discuss my solution. Okay, so the example that they gave you is like this. Um, there is a staircase and it has three steps. Unfortunately, they used a zero index, so it will not make sense in the idea of stairs. So when I say step zero, I don't mean the step zero because to me this is the first step. But again, these are the indexes of the array. We are going to use that so that we don't confuse ourselves. So for this example, step zero means the step that's labeled zero. Okay, and they gave us a couple of examples. Actually, let me check if they gave us more than one. I think that would be a good way. Yes, so we are going to do both examples, and that I think would make sense for people. So the first example was 10, 15, 20, 10, 15, 20. And there's one more thing that it has a potential to confuse people, that there is an implicit top step that is free to stand on. Okay, that's the top step. And there is obviously the ground step that is also free to stand on. This is ground. If it was up to me, I would have put a zero over there and a zero over there just for clarity. But again, the question does not seem to think that's important, so we're not going to do that. The way to solve this is you keep track. So this is an example of a dynamic programming question where you use uh, uh, subproblems. Well, a combination of subproblems, some kind of a combination, okay? Combination of subproblems. Let's come to a more general case for a minute, okay? Uh, yeah, I think we should start there because in dynamic programming, you have to think about the kth step and what other step before yourself, what other smaller problem, k minus 1 is a smaller problem, k minus 2 is an even smaller problem. You can think of what other steps do you need to combine to get your current step answer, okay? So the question is to get the minimum cost, okay? So we are going to ask the same question to the ones before. What's the minimum cost of getting to step k minus 1? Okay, that's my question for k minus 1. What's the minimum cost for coming to step k minus 2? The reason I'm asking only these two guys is because they are the only steps that matter. I can either take one step from the k minus 1 or a larger one step from k minus 2. And then pay the price for coming to this step, okay? So cost sub k, I have to pay this to come to this step, right? But it matters whether or not I come from k minus 1 or k minus 2, because imagine whatever steps I took, in order to come to k minus 2, suppose I took a bad route, okay? I paid 102 coming here. Suppose I did not take a bad route. Suppose I have 50 to come here. So which route should I extend, right? Question is, should I add my current cost to that 50 or to that 102? Because if I extend this route and I say, okay, this is my route, I have to pay a lot more. I have to pay about $50 more than if I had continued whatever this route was, okay? So the idea is you always continue the winning route. So we are going to cancel this out because that doesn't win. This is the winning route. That's why we are going to use that. And so we are going to use an array. You don't really need to use an array. The array uses O of n space. You could have used a constant space if you just kept track of two pointers, I mean two integers, the cost of the step before you and the one before that, that's all. But for the sake of this problem, it doesn't make sense to optimize it for now. We are not going to use that. So that's what this array is. And now we get to name this. It's called winning cost. See, it makes sense because if you come here, you have taken the optimal path. Okay. So think about it now. If you want to come to step 0, how much do you pay? You obviously pay the base fee for that step. And what's the base fee? 10 bucks. We pay 10. Cool. I'm not going to use red for this, yellow. This is not the same as the cost. This is the winning cost of coming to this step, the least cost that I have to pay. Okay, think about the ways of coming to step. Again, this is step 1 because it's indexed at 1. Okay, I'm going to call it step 1. It's very uncomfortable for me to do that, but yeah, this is step 1. You can come from the step before or you can come from the ground. If you come from the ground, you don't pay, you only pay the current fee for that step. You don't need to pay the fee for step 0. If you come from step 1, you have to pay the fee for step, you have to pay the fee for step 1. Excuse me, I think I'm mixing that up. Let me come again. If you come from step 0, you have to pay this fee and that fee. If you come from the ground, you only have to pay this fee, okay? So this is a base case. You can think of it as a base case. There is no logic here. You only pay at step 1, you pay this fee. At step 1, you pay this fee, okay? I meant to say the other one. So this is 15. Now begins the logic. You don't think about any of the steps before. You already have the winning value. So that's what you're going to use to calculate this step. Okay. You can either come from step 1 and then pay step 2 base fee, or come from step 0 and then pay the step 2 base fee. Okay. Let's think about that for a minute. That would look like, I'm going to use black, math math.min winning cost. Let's think about coming from the step just before it. So in this case, that happens to be 1 versus winning cost coming from that step, which is step 0. And that would be minimum of, and that plus my cost of being at the current step, which is 2, right? So minimum of, what's the cost of, I'm sorry, I did not mean to show the top. I meant to say this and that. Okay, so what's the cost of coming from step 1, index 1? That's 15. We have that right here. What's the cost of coming from the step before that, step index 0? That's 10. So minimum of 10 and 15 plus what's the cost of staying here? 20. So to get to step 2, the minimum cost we need to pay, we have to pay the step fee, and then we have to take the minimum that we can get away with. So that ends up being 30. Okay, so this would be 30. We are not done yet because we have to take one more step, because the question I don't think was very clear on that, but that's ambiguous to me. But we have to take another step to the top, right? There is a top, there is a ground, they're implicit. Now, once we have that, we now have to think about what's the cost of getting to the top from the nth step and the n minus 1 step. We have to do the same comparison again. Okay, so that would be minimum of coming from here. That's 30. We calculated before. or coming from here, which happens to be 15, plus the base fee for this step. Again, there is no fee at the top. So that's 0. So minimum of 15 and 30 is, sorry, 15, and you return this answer. Now we are gonna try to do the next problem, example they gave us, so that we understand what's going on. I'm gonna try to pause the video and copy it over. Just a moment. Okay, I have it right in front of me, so that you don't have to sit through me drawing it out. As we discussed before, these two are the base cases. It doesn't make sense to pay this step fee in order to come to here, so you only pay the second step fee. Anyways, now the base cases are done. Let's think about how to come to step 2, and we are going to go through this, and it will make sense, hopefully. You are going to be able to program it yourself. Even I'm just going to show you my code too. So let's think about it. I'm going to use green, excuse me. I have to pay the base fee, obviously. What's the base fee at step 2? It happens to be 1. Plus, I'm going to have to take the minimum of the winning numbers from before. What's the winning number? The minimum cost I have to pay to step 1 is 100. Okay, that's not 100. Sorry, this should be, no, yeah, it is 100, because either I pay 100 directly or I pay 1 plus 100, 101. Anyways, so that is the winning number so far. Not a great one, but that is what it is. Okay, so that's 1 plus, the minimum is 1, so I come here with 1 plus 1 is 2. Again, I'm just going to draw out the path for you. You avoid that step at all costs because it's so expensive. Same with that step. We're going to avoid those steps. So the route is like this. You come here and jump over that expensive step. If you, by mistake, come here, you're going to have to pay a lot. So don't go there. Okay, so that's that. Let's talk about step 3. Again, step at index 3. That's not step 3. Okay, so you have to pay the base cost at that step. The base cost is $1, and I'm going to remove that. And the minimum of the winning cost from before. What's the winning cost over here? Oh, you have to pay a lot. Okay, that's 100. What's the winning cost over here in the step before? That's just 2. Definitely not this. So I take whatever route comes through here, right? And we know that route happens to be like this. We are going to extend that route. Okay, we're going to come through there and here. So 2 plus 1, we are going to put this to 3. Okay, so that's our winning route so far. Actually, why don't I keep track of it? Let's keep track of it. Okay, so we came here, but we are not keeping track of this route in our program. We just need to keep track of the number. Okay, that's why I kept erasing it. And then we took a step from here because it's not as expensive. Okay, think about step 4. How much do you have to pay at step 4? You have to pay just $1. Okay, so you pay the $1. Now, where do you come from? Are you allowed to come from step 3? So minimum of, let's take this one. The minimum cost of coming to step index 2 is 2. The minimum cost of coming to step index 3 is 3. Huh, that's nice. So minimum of 2 and 3. Obviously, we're going to come through the cheaper step. We're not going to use that one. So 1 plus 2 is 3. So actually, we're not taking this step. See how we did not extend that any further? We are going to use the cheapest route to come here. So we have actually skipped step 3. So that's, how much was that? That's 3. Okay. So that's the winning number now. Okay, let me come to step 5. Actually, we are going to have to step over that because that's so expensive. But let's go through the routine. So we pay 100. We have to all the minimum price of everything before it, right? So minimum of everything up to step 4, which is 3 and 3. That's fun. I can take any. I can jump from. Oh, in order to come to step 5, I can either jump. I'm going to use a different color because we're still thinking about it. I can either jump from here or here. It doesn't matter. I'm paying lot. I'm paying 103. So actually, 103. So this is our tentative step. We are going to remove this soon. Either this one or that. Okay. But we're not actually going to take it because we're going to take a bigger jump. Okay, so we are thinking about at step six. Normally, the base pay uh, fare for this step, not six, is one, right? And then minimum of, okay, how much do you have to pay to come to step five? You have to pay 103. Okay, that's a lot. So we're not gonna use that. Versus if you take a shortcut from step four, you jump above, you only pay three. So definitely not this, so four. So we are not even going to consider that. We are jumping straight from step four to step six. And we're going to record that as four over here. And you get the idea. Let's try to go a little more fast. So at step seven, the base is one plus the cost before. You're again comparing between 103 minimum of these two. So 4 plus 1 is 5. This is the minimum, by the way, and we know. And let's think a little more. So we're gonna trace out the steps later. Actually, no. Which one did I take? I took this path. Definitely not step 5 because that's very expensive. Okay, at step eight, okay, we're gonna skip that definitely like this, but let's go through the process. At step eight, the base cost is 100, so that's very expensive. And then minimum of the steps before. So those are five and four. So five versus four. The best case is I have 104. So the best case is like this if I want to come here, but I don't actually want to come here because that's so expensive. 104, right? We are going to keep track of that. And then, so we took the step from here, right? But we're going to erase that in the next round. At step nine, the base pay is $1. You have to pay that. Do you want to continue the route from eight? Definitely not. So, but let's say that minimum of this is the route from 8, 104, very expensive, versus the route from 7, very cheap, 5. So 5 plus 1, 6. So I have 6. So we remove that. So I actually jump from 7 to 9. We are not done yet. So I initially got very confused with this question because of this. There is an imaginary top step. You still have to come here. You have to do two more. You have to do another comparison. You have to compare between coming from step 8 all the ways. We considered that in here. The best way was this, very expensive, versus this. You still have to make that comparison. So you have to do 0 plus minimum of the step right before is 6. The step 2 steps before is step 8. So that happens to be the winning cost there is 104. That's the best case scenario for that. Definitely skip that. So we are gonna continue this. Okay. So and there is no cost here. Yeah, I already told you. And we are gonna continue this route and we get to the top. Okay, I think that's enough explanation of why this works, how this works. And again, if you think about it, you only need to keep track of two steps before you at any steps, so you do not need the full O of n array. You can do O of one memory with the constant time. Anyways, let's look at the code now. So I'm just going to explain my variables. N is the length of the list stairs that you have to pay for, but remember there is a ground floor and the top floor that are free to stand on. And then this is my array. It's called winning cost. And again, it could have been two integers, but I'm using it as an array for our example. And so we are going to set the base case. Winning cost 0 is the cost of 0. Actually, I'm going to take a risk and change this because while I was explaining this, I remembered that, huh, I never have to come through this first step. So I'm going to do that, and hopefully it works. Anyway, so these are the base case. At step 0, I said you pay the cost to get there. At step 1, you don't add the cost, you just jump there. That's it. And at I wanna I wanna change all this and see what happens. Return winning cost sub 1. If it doesn't work, I'm gonna think together with you guys why it doesn't work. So I'm saying these two are base cases, right? And then n equals 2, and then I go from so n equals 1 means array index 0, n equals 2 means there are only 2 indexes, so I have to go up to array index 1, and then the next index would be array index 2. That's why this is I equals 2. But at this point in the code, this is n equals 3. N equals 3, right? But n equals 3 means my index is 2. That's why I am continuing from 2, because at this point index was 1. At this point index was 0. Uh, this confused me a little, but that's why it's this way. So the for loop has to start at I equals 2, I less than n. If you do the other way, less than or equal to, you can change that, but I'm not doing that. Anyways, so this is our current problem. In order to solve this, we are gonna add our current value. This is the, if I need to step on this step, okay? Plus, which way do I pick? Do I pick the way coming from the one just before, or the way coming from 2 steps before? Okay, whichever is the better one, we pick. In this case, we're looking for minimums. We take the minimum cost. Okay, we can also maximize the cost like this if we need to, but in this question, we're minimizing the cost. Okay, and then so at the end of this, you end up with all the steps accounted for. Now, where are you at this point? You have in your array up to O of n minus 1. You're not at the top yet. You have to do one more comparison to get to the top, right? So you have to compare whether you take the last step to the top from the n minus 1 step, that's your paid step, the last paid step, or the second paid step. Which one do you take your last step from? You decide right in here, and this 0 I just put there so that it tells me that there is nothing. The last step is free. Okay, so that's the idea. I just changed this code and I hope this makes sense. Let's see if this runs. If not, I'm gonna try to solve it somehow. It didn't run, so let me pause the video and fix it and share the fix with you. Okay, I found the issue. The issue was I typed this wrong because I copied it. I said array sub 0. That didn't make sense. That's why that was wrong. So I fixed that. I put the second element to the second element because, again, we should not add the value for the first element here. The other change I made was this does not make sense because, again, I forgot that I have to take one more step. N equals 2 means I have 2 paid stairs. After the 2 paid stairs, I have to take one more step to get to the top. I forgot to take that step again. That's why that was wrong. So this doesn't make sense. But these two are like base cases. I think of them that way. And then this is if there is one step, we have to take that step. If there are 2 steps, we can take either step. We compare which step we take. If there are more than that, we do the thing. And then from the last step and the step before that, we decide where to go to the top. I'm going to submit and show you that this code works. And there, it got 100%. That's good. I use some memory. Again, I could have decreased this memory to a constant time by only keeping track of 2 variables instead of all these n variables. I think that concludes my presentation. If you have any questions, please put them in the comments and let me know. Thank you.